In this lesson, lesson 2.5, we're going to be looking at the graph of y equals k times x squared. But before we do that, let's start out this section by talking about rate of change. Remember, rate of change is the same as slope. That's something that we talked about in the previous section. But in the previous section, we looked at y equals k times x. We were looking at straight lines. But to find the slope, remember we took y2 minus y1 divided by x2 minus x1, or the change in y divided by the change in x. Well, we can apply this concept of slope or rates of change to curved lines in addition to just straight lines. But first, let's look at the story problem. It says, find the following rates of change and explain what each means in terms of braking distance. So what this graph represents is this is looking at different speeds, and if you were to slam on your brakes, the distance in feet it would take to come to a complete stop. So the question here is asking us to find the rate of change from 20/20 to 40/80. Or in other words, if going from 20 miles per hour to 40 hours per hour, you want to figure out the rate of change in your braking distance. So the way we're going to set this up is we're going to take and subtract our y's, 80 minus 20, over our x's, 40 minus 20. Well, 80 minus 20 gives me 60, 40 minus 20 gives me 20. We could simplify that to say our answer is 3. But remember, we're looking at, this is a story problem. So we want to make sure that when it asks us to explain what each answer means in terms of braking distance, that we're answering the question. And just saying 3 doesn't really explain much. But remember, back in elementary school, they taught us to, if we had 3 over 1, that we could simplify that to be just 3. We need to keep that in mind because that'll help us interpret this answer. Now remember, the numerator represents the change in y, or your braking distance, your change in braking distance. The denominator represents your change in x, in this case your change in speed. So the way that we could describe our answer is looking at a denominator, we could say for every increase of 1 mile per hour, dealing with our speed, you need 3 more feet to stop, referring to your braking distance. That's just one way we could describe our answer. Let's look at another example. Now let's say if we're going from 40 miles an hour to 60 miles an hour, our braking distances are going to go from 80 feet to 180 feet. We want to find the rate of change for this scenario. So again, I would take 180 minus 80 divided by 60 minus 40. 180 minus 80 is 100. 60 minus 40 is 20. And we could simplify that to be 5. But again, 5 is the same as 5 over 1. It just helps us to interpret our answer now to say that for every increase of 1 mile per hour, you need 5 more feet to stop. So that's how rate of change applies to a curved line. Remember, we just always need to have 2 coordinates. Once we have those 2 coordinates, you just use your slope formula to find the rate of change. Now let's look at the graph. Before we get to the graph, let's just talk about some basics here. Anytime we have something in this form, y equals k times x squared, like y equals 2x squared, or even just y equals x squared, that's going to be in the shape of what we call a parabola. And you should already recognize what a parabola looks like. It's going to be a curved line looking like either of these two. Now all of these parabolas are going to pass through, when they're in this form, y equals k times x squared, are always going to pass through the point 0, 0. We call that point the vertex. And each parabola, the y-axis, the vertical line, the y-axis is called the axis of symmetry. Now let's look at some things. I'm going to show you some things about with your calculator that we can do here. So first, let's go to a graphing screen. Now what we're going to do is we're going to insert what's called a slider. To do that, we're going to put in k times x squared. Now this is something important here. Notice how I put the symbol times in there. If you just put kx squared, your calculator is going to look at that as being the variable kx, not the variable k times x squared. So that's why I need to have the times symbol in there. That's very important for what we're going to be doing. Now if you hit enter, nothing happened. Well, that's because your graph right now, your calculator knows how to graph x squared, but it doesn't know what to do with the k. So what we're going to do is we're going to do what's called inserting a slider. So if you go to Menu, and under the Actions, at the very bottom it says Insert Slider. And in this version, some calculators will automatically put this slider someplace, but with this operating system it allows you to move it around. But before you do anything, don't just hit enter, because notice how it says v of 1 equals 5. They've named this slider v. Well, we don't want to name it v, we want to name it k. So just type in k and hit enter. Now what we can do is we can move this slider to the left or to the right to see how different values of k affects this graph. Now I want to see how negatives are going to come into play here, how negative values for k is going to affect my graph. So what I want to do is I want to make sure that this box is selected. Make sure k isn't selected, or your hand isn't on here. Just go over, make sure the box is selected, and hit Control and then Menu. And this box comes up so we can change our settings. Don't do anything with the variable. But here's where if you had accidentally typed in enter and something else was labeled there, this is where we could change now that variable to be k. But I'm going to put my minimum, my starting value, I'm going to change that to be, just use -10. Now step size, if I tab down here, is basically asking you when we go into increasing, what increments do you want to change each time. So we want it to increase by, you can do 1. Let's just do, I don't know what happened here. Let's do it by 0.5. And just go ahead and hit enter a couple times so that box is gone. Now here's something neat that we can do. If you go back, if you still have this selected, hit Control Menu again and animate. And what this is going to do now is this is going to automatically, if you notice our slider, it's changing. It's moving from right to left. And it's also, we can look at our values for k. Now we can look to see how these values of k are affecting our graph. Now notice as k gets further away from 0 here, the graph is actually getting narrower. In other words, the larger, or like if we had 10x squared, the narrower the graph is going to be. Or if I had just y equals x squared, the wider the graph is going to be. So the closer the graph gets to 0, as you can see, the wider the graph gets. Now remember when we talked about the constant of variation, we say the one number that k can't be is 0. Well, as you've watched this video, you can see that when k hits to be exactly 0, which it'll come down to here in a second, it'll be a straight line, and a straight line is not a parabola. So that's why k can never be 0 for any of these problems. So from this we can get some other information here. So let's go back to our notes. So first off, we've talked about domain and range. The domain here is going to be the set of all real numbers. Now when k is greater than 0, the range is going to be the set of non-negative real numbers. Or another way to look at that is it's going to be when k is 0, the range is going to be the set of y's where y is greater than or equal to 0. That would be another way to write it. The reason why we say non-negative is because it includes 0, and 0 is neither positive nor negative. So if you just said the range was all the positive real numbers, that would actually be wrong because you'd be leaving out 0. So that's why it's important to say that it's a set of non-negative real numbers, or an easier way to write it is just as I have over here. Now in this case, when k is greater than 0, when k is positive, the graph opens upwards. And in that case, the vertex is what we would call the minimum point. Now when k is, this is supposed to say less than 0, when k is less than 0, the range is going to be the set of non-positive real numbers, because remember the parabola in this case was opening down. Or another way that we could write the range here is we could say it's a set of y's where y is less than or equal to 0. But in this case, the vertex is going to be what we call the maximum point. And this box here summarizes what we just talked about and summarizes what we were looking at with the graph. So hopefully now parabolas are more clear to you, and good luck in your assignment.